I joined the Army at 17 because the reality is I was more afraid of a college classroom than I was of a war zone. I served as an airborne combat medic, and during my time in Afghanistan, I witnessed and treated numerous traumatic brain injuries. And then one day, I became a victim of one myself. But those experiences spurred my motivation to go from patient to Ph.D. in the field of neuroregeneration. It's this intersection between neuroscience and stem cell medicine, where I hope to contribute a few things. One, I want to deliver to the field a more simplistic brain injury model, one that better represents the way that humans experience a brain injury, but then applied to a model organism where we can also study regeneration. Secondly, I am interested in injury-induced neuronal regeneration, or in other words, how can we use adult stem cells to replace lost and damaged neurons? Currently, most of this work is conducted in rodents, but they're expensive, they're time-consuming, and they do not have the ability to regenerate. That limits us to investigating only the injury itself, whereas I work in the adult zebrafish, which, though tiny, it shares 80% of the same DNA as humans, except they're extremely regenerative. From the moment they're born until the very end, they can regrow their eyes, their heart, their brain. Almost everything can regrow. But I'm not the first person to look at a brain injury in zebrafish, but it's been done almost exclusively by taking a needle and stabbing a portion of the brain. And that's more comparable to a gunshot wound, and unfortunately, most people don't survive that type of injury. So what I've done that is new is I've brought to the field a blunt force model. Again, better representing the way that humans experience a brain injury. And that's just a good old-fashioned bump on the head, where, just like people, my zebrafish experience some consequences. Things like seizures and brain bleeds, learning and memory issues. So we too can investigate that injury just like they do in rodents, as well as their recovery, as they start to regenerate a few days later. The first half of my dissertation was spent on developing and validating that injury model, where now I aim to better understand the gene regulation leading to that neuronal regeneration. You can think of genes as a series of light switches where some are turned on and off throughout your entire life. What I aim to do is collect these white dots. These are injury-induced adult stem cells. I want to know their gene regulation. I want to know what series of light switches are turned on and off and in what order that allows the adult zebrafish to replace lost and damaged neurons after a brain injury. So when I do this, I will get a list of genes, where some of these genes will be turned on and I will turn them off. Others will be turned off and I will turn those genes back on to get a better understanding of their individual role and contribution to regeneration. Hopefully one day contributing to a possible therapeutic for all neurodegenerative diseases. Thank you. Thank you.
Well, Jamie, on behalf of everybody in the audience, first, thanks for your service to our country. So a question for you. I hear in your free time, you're engaged in Brazilian Jiu-Jitsu.
Yes. So is Ms. Jordan Cockfield over here.
All right, very good. So talk to us a little bit about Jiu-Jitsu, if we're not familiar with it.
So Brazilian Jiu-Jitsu, going kind of along with this theme, is a combat sport, but it is a combat sport that I choose very specifically because I do have a brain injury. It is the safest combat sport for head injuries because it does not involve striking, and it's predominantly on the ground. So there's not a lot of falling or throwing or aspects of hitting your head. It's mainly blood and joint manipulation.
Very good. So talk to us a little bit about the pins on your jacket.
Yes, so I served as an airborne combat medic, as I said. So below is my airborne wings, and then above is a combat medical badge, which I earned in Afghanistan for treating service members underneath fire.
Very good. So, thanks so much.
Thank you.
Appreciate it.
Thank you.